Okay, thank you so much, sir. So children, let me quickly tell you about the flow of the session. So first of all, you'll get to know your mentor. Then you'll see a short informative PPT. You can note down if you want to note down anything. Then you will go through a virtual tour of the dashboard of Olympiad Success, wherein you will learn how to access reading materials and all. And then it will be followed by a short question answer round. In case you have a doubt, you can ask then and there. And then the actual demo will begin, for which all of you have been waiting. Okay. So I hope this flow of the session is clear to you. Show me a thumbs up if it is clear. Okay, it is clear to Atharv. Okay, all right. Now, right. So those who have joined just now, please switch on your cameras. Right. Mohammed, please switch on your camera. Okay, nice. Very good. So let me tell you that we have with us Aishwarya ma'am, and she's a wonderful mentor. She's subject matter expertise of science, and she loves to interact with kids like you. She has got substantial experience. She has been associated with us for quite some time now. So I would request Aishwarya ma'am to speak directly to you. So all over to you, ma'am.
Thank you, ma'am. Hi, everyone. How's everyone doing today? Good? Feeling good about today's demo, everyone? No? I'm not getting... Okay, great. Good to see some smiles on screen. So my name is Aishwarya. I am from Delhi. And I, like ma'am said, I love interacting with students. I love having a good interactive session in class. So when you come to my class, come with a lot of energy, okay, and come with as many questions as you can, right? So you have to be curious in my class, because either two things can happen. Either you don't understand anything, that is why you're not asking questions, or you understand everything, that I'm such a good teacher that you understand everything. So only these two are the possibilities if you're not asking questions, right? So come to my class, ask as many questions as possible, and we will have a good learning experience. So a little bit about my background. I have done an MPhil in botany, and currently I'm pursuing my PhD also in botany. So obviously my expertise lie in science only. And other than that, I've been teaching for competitive exams for quite a while now. It's been almost 4.5 years. And I have been associated with Olympiad Success for a long time now. So it's good to have a new batch with us today. I hope all of you enjoyed the demo and we'll have a good time in the regular classes. Thank you.
Thank you so much, ma'am. Now, children, allow me to share my screen for a short PPT. Just a moment. And we are good to go. I hope my screen is visible to all.
Yes, ma'am.
Thank you. So a very warm welcome to each one of you to the demo and interaction program for Class 6 Science Batch 3. As you're already aware, Olympiad Success is India's largest online preparation platform for Olympiad exams. Olympiad Success Live is India's first exclusive live classes for Olympiad's preparation. School Plus by Olympiad Success is one of its own kind of annual program that includes 8 courses that really matter at this juncture of your life. And these 8 courses include mathematics, English, science, logical reasoning, communication, both spoken and written, Vedic math, and coding. So here you get one-on-one online CBSE, ICSE, IGCSE, and IB classes for grades 2 to 12. One-on-one preparation classes for international mathematics Olympiads like SASNO, CMO, HKIMO, TIMO, Math Counts, US Common Core Math Competition, Math Kangaroo, and PRMO. So you can meet our international rank holders for the year 2022-23 on the screen, and for the year 2021-22. And these are so many kids like you. Okay. Now the classes are going to be group sessions with batch size of around 20 students delivered through Zoom by experienced tutors. You've already met your mentor. So you get 3 sessions per week, Tuesdays, Thursdays, and Saturdays. Timing will be 8 p.m. till 9:15 p.m. with 5 minutes of break in between. So this means 35 minutes of class with 5 minutes of break. Again, 35 minutes of class. And the classes are going to be a mix of theory, practice questions, doubt sessions, and discussion on previous year papers. You get access to reading material and practice questions available on the dashboard of Olympiad Success. How to access those? You will go through a virtual tour by Rajat sir, and he will show you how to do that. You also get free access to Olympiad Success Platform so that you can practice topic-wise mock tests for both science and reasoning, as well as logical reasoning. Now, the syllabus is available at this particular link, and fees can be paid by clicking on this particular link. Don't worry, all the important and relevant links will be pasted again in the chat box. The fees for this course is rupees 11,151 rupees, and it is going to be a 50-session course. The fee includes online classes, daily reading notes and exercises, practice of previous year papers, and access to Olympiad Success Platform for science and logical reasoning. Now, all that you require for these classes is your mental and physical presence. And apart from that, you need a laptop or a desktop with good internet speed, with camera, because we do not allow students without video in the class, and headphones for better audio clarity. Now, preparation for Olympiad exams is slightly tougher than your regular school curriculum. So you need to spend at least 2 hours every day so that you can cope up with the curriculum. And of course, parental support is required at the back end. So in 2022-23, Olympiad Success had students from more than 3,850 schools across India, hailing from 35 plus countries. Now the live classes for this particular batch begins from Thursday, 22nd of June, 2023. I hope you've noted down all the relevant details that you were interested in. Now I would request Rajan sir to take you through a virtual tour of the dashboard of Olympiad Success.
Sure, ma'am. Thank you for the wonderful presentation. Let me share my screen. I hope students, my screen is visible. So this is the website of Olympiad Success. I'm just showing you how you can access the content. What you need to do, you need to click on my account. And here you need to enter the credentials. So once you enroll with us, we will share the credentials with you. With that, you can log in. Let me log in with my credential for now. Click on sign in. And here you can see this is the student profile and all the content you will find here in the live classes. Click on live classes, then you need to choose a subject. So in our case, it is Science Olympiad. Then you need to choose a topic. So for each and every topic, you will find the reading material and practice questions here. So I have choose this motion and measurement of distance. Let me show you how it looks like. So this is the reading material for this particular topic. Okay. Other files are also there for this particular topic. Similarly, you can see practice questions and answer keys are also available. Let me show you how it looks like. So these are the questions for this particular topic. Okay, all are MCQ based. Other than that, students, you can also check schedule here, like in which session, which topic we are planning to cover. So this is the schedule. Like in session 1, we will cover food and its components. In session 2 and session 3 and session 4, we will move this move with this topic only. And in session 5, we have a test discussion. So after each and every chapter, there will be a test discussion. We will share the mock test with you, and we can discuss that test in the classes. Okay. And like Monica mentioned, in the live classes, we will also discuss previous year Olympiad questions. So at the end of the schedule, you can see we have super classes. So in the super classes, we are going to discuss all previous year Olympiad questions for grade 6 science. Okay. Now, other than that, students, you can also check holiday calendar here, like on which holidays you don't have the classes. Other than that, with this course, you will also get free access to the Olympiad Success dashboard for mock test, for logical reasoning, as well as for science that you can access here from worksheets. What you need to do, you need to choose a subject. So with this course, you can access for logical reasoning as well as for science. So these are topic-wise mock tests for science. What you need to do, you need to click on take exam to attempt it. Many more topic mock tests are available here. Okay, you can click on next to see that. Now, after completing the test, you can check your performance here in the performance tab. You just need to select the subject. Let me choose logical reasoning. Then just click on detailed result view to check the answers. Okay. So this is all about the dashboard, students. Now, if anyone have any doubt or query, you can put in the chat box. Do anyone have any doubt or query?
Please feel free to ask. Don't keep your doubt to yourself.
No? Okay. Anyone with any query or doubt related to the course? Okay, you can think if you have any query. In the meantime, let me ask some questions to you. Can you tell me the days on which you're having the classes? Then put in the chat box. Anyone? Yes, Ashish, you can type in the chat box if you have any doubt or query. Anyone remember the days on which you're having the classes? Tuesday, Thursday, Saturday. Okay. Any other answer? Is it correct? Yes, Tuesday, Thursday, Saturday. Yeah, correct. The timing is Tuesday, Thursday, and Saturday. And what are the class timing? The days are Tuesday, Thursday, Saturday. What are the timings for the classes? 8 to 9. Is it correct? Yes, Ashish, you can type in the chat box.
Type your
We'll
question.
answer your query.
Whatever doubt you have, just type it in the chat box.
Yes, correct timing is 8 to 9:15 p.m. Not 8 to 9, it is 8 to 9:15 p.m. Are you typing, Ashish? Please repeat regarding test. Yeah, so after each and every chapter, there will be a mock test. Okay, we'll share the mock test with you that you need to attempt at home, and we will discuss that mock test in the class. Other than that, like in the content, you will get mock test series. So like for each and every chapter, a lot of tests are there that you can attempt online, and you can check your result, and you can also check the analytics, like how many questions were attempted, how many are correct, how many are wrong. Okay, average score and your score. This is what you're asking, Ashish, or any other doubt?
Anybody else has a doubt? No doubts.
No.
Okay.
Okay.
I think we are good to go now.
Please unmute. Ashish, for the demo session, we actually not unmute. Okay, so you can type in the chat box. We will answer you. Still, if you want to talk to someone, let me share the links in the chat box. So there is our WhatsApp number at the top. Okay, you can call on this number and someone from our team will help you. I have posted the links in the chat box. So at the top, you can see there is a WhatsApp number. You can message or call on this number and someone from our team will help you regarding that. Okay.
So Ashish, this setting is only for today's demo. Otherwise, in your regular classes, you will be free to speak. Okay. Okay.
Okay. Okay, then students, I think we can start with the session. In case if anyone have any doubt, I've just posted the links and at the top there is our WhatsApp number. You can message on that and someone from our team will definitely help you regarding that. Okay, so let's start with the demo for today. So over to you, Aishwarya ma'am. Yes, ma'am, we can start.
All right. Okay. All right. First of all, those of you, I think Madhura and Nilargaya, I hope I'm pronouncing your name correctly. Can you please switch on your video? It's not a nice thing to see a blank screen. Please switch on your videos. All right. Thank you. Hi, Madhura. See, it's nice to have a name and face associated. All right. So, sir, I think Ashish has a doubt. Do you like to clear that and then I can start it?
Yeah, sure. You're speaking very fast. Please go smoothly. Note understanding regarding app. Okay, so regarding app, what you can do, you can check the recording again. The link I've shared with you now. There's our Facebook page link also there. Okay, so we'll upload the recording also there. You can watch the recording again. And still, if you have any doubt, you can message on the number that I have shared, and someone from our team will help regarding that. Okay, Ashish.
Shall I start? Okay, so today for demo, we are going to talk about, let me just share my screen first. We are going to talk about sorting and separation, okay? So before I talk about how you sort out materials and how you separate out different types of materials, can someone tell me what do you understand by matter? Put it in the chat box, whatever is your answer, put it in the chat box. What do you understand by the term matter? And give me an example maybe. If you don't know the exact definition, you can give me an example of matter. What do you think according to you is matter? Yes, I'm waiting for answers. Everything. Okay, Madhura. Correct. Everything around us is matter. Okay, good, Rihas. An object that occupies space. Just space. Okay, correct. Like air. All right. Ashish is saying matter is made up of molecules. Example of book. Very good. Solid building block. Liquid, water, gas, oxygen. Good, Anayata. And Atharva is saying a thing which occupies space and mass. That is known as matter. Very good. So I think all of you are clear with the definition. So the main definition of matter is that anything that occupies space and has mass, that is called matter, right? And the examples that you've given, like in the sense, water, jar, solid block, building block, anything that you all have said is correct. So whenever we are talking about matter, first we'll try to understand the physical and chemical properties of matter. Once we've understood what exactly are the physical and chemical properties of matter, then we'll try to understand how we can sort them out or how we can separate different matters from each other, right? So first of all, I'll finish like how we go about the flow of things is I will talk about a topic or any particular slide or something, and then when I ask you if you have a doubt, you can put the doubt in your chat box. Is that okay? All right. Now, first of all, everything around you is matter. Whether it is air, whether it is oxygen, whether it is water, whether it is your table, whether it is your pen, your laptop, your desktop, anything that is around you is matter. So matter can exist in the form of gases, it can exist in the form of liquids, and it can exist in the form of solids. So anything that has mass and takes up space or it has volume. Okay, can someone name two things that are not matter? Something that is not matter. Very good, Athar. Vacuum is not matter. Why? Vacuum doesn't have? Yes. Air is matter. Electricity, correct. Right. Vacuum and light or sunlight, these are substances which are not matter. Air is matter. Why? Because air has a mass and it has a volume. It might not have a definite shape, but it has. People's clothing, Vaishnavi, it is matter. Any kind of substance which has mass and volume, that is matter. Correct. Gravity is not. People are also matter. We have a mass. We are occupying space. So we are also a part of matter. Yeah, reflections, they are not matter. Very good. Okay. Now, there are different states of matter, like I told you. Now, normally, when we look at the substances or we look at the different types of matter, we try to sort them out or we try to identify different physical characteristics about them, and then we try to identify some chemical characteristics about them so that they have distinct features, and then we'll be able to distinct them between other substances. For example, if I have air and water, even if you don't see air, you know what air is. right? You can't see air normally. It's not visible by the naked eye. But if I say that air is a gas particle or air can move freely around you, you know that air is moving freely around you, right? So you know the characteristics of air, correct? So these are certain characteristics of matter on which we will try to differentiate all of them. First is appearance. Appearance means how they look. So we have color, texture, whether it is hard, whether it is soft, whether it has luster. Luster means that whether it is shiny or not, whether it is dull looking. So like that, we'll try to characterize the appearance. Second way in which we characterize the matter is based on their solubility. That means whether or not it is soluble or it is miscible in different substances, mainly water. If it is soluble in water, it dissolves completely in water, we call it soluble. If it doesn't completely dissolve in water, we call it insoluble. For example, let's say soluble will be if I take a spoonful of salt and I want to dissolve it in water, will it dissolve? I stir it around, it'll dissolve. It'll dissolve, right? So that's soluble. What about sand in water? Is it soluble or insoluble? No, correct. It is insoluble. Those of you who are taking little time to write down in the chat, you can also use your thumbs up or thumbs down or anything from the emoticons, right? Okay, next type of characteristic is either they are metals or they are non-metals. Now, metals are mostly substances which are very, very reactive. Okay, so they react easily to anything, and non-metals are not very reactive. That means they'll not easily mix up with other substances. So we will categorize them on that basis. And the last one is whether or not they emit light. Yes, Atharv, sodium is one of the metals. So light transmission means if an object is opaque, that means no light passes through that. Okay. No light can pass through it. For example, your laptop, you itself, you're opaque. Okay. Next, we have translucent. Translucent means some light passes through it. Okay, let's say a plastic sheet is there, or slightly, butter paper is there, a wet tissue paper is there, or let's say the windows on your washroom, they are slightly frosted, so they are translucent, and transparent will be all light will pass through it. So like in the case of glass is completely transparent. Okay, any doubt in these 4 features? We will talk about them in detail also, but overall, is there any doubt? Yeah, there can be a transparent pad also. Okay, great. All right, now moving on to different states of matter. So normally we know 3 states of matter, right? So what are the 3 states of matter? Solid, liquid, and gas. Now, apart from solid, liquid, and gas, we have 2 more states of matter. One is plasma. Plasma is a gaseous state, but at very, very, very high temperatures. That means when gases are converted to something, or gases exist in thousands and thousands of temperatures, at that temperature, it is known as plasma. Best example of plasma is your sun. So sun is what? Sun is just a ball of gases, right? Plus it's really hot in temperature, correct? And that is why it is emitting out so much light, and it is reaching as far as the Earth and as far as, of course, Neptune as well. So, correct. Plasma can be made up of number of gases, which are mostly noble gases. Yes, they are usually 3000 degrees Celsius. So, very high temperatures of gases, when they come together, they are known as plasma. So, the features are same only. They don't have a definite shape, but they have a definite volume. Okay, and they will function, or their main characteristics are like gases only. That means the particle movement and everything is similar to gases. Only thing is they're at very high temperatures. All right. So in general, we see the plasma as an example, which is the sun only. Now the 5th type of state of matter is Bose-Einstein condensate. Bose-Einstein condensate are particles that are formed when any gas or any substance goes to very, very low temperatures. Okay. Now, this is something that we have made ourselves. That means it is a man-made state in which gases are existing at very low temperatures without changing its state to liquid or solid. Normally, what happens if I cool down a gas will convert to liquid and liquid will convert to solid, right? If water vapor is cooled down, water vapor will become water. And if water is cooled down, it will become ice. So gases cools down to become liquid, liquids cool down to become solids. But in the case of Bose-Einstein condensate, they are just a group of gases which are existing at very low temperatures. There is no practical example to it, Atharv. We don't have any practical use also to it. All right. We just have discovered this because they can live in that state. But as of now, we don't have any practical use of it. And we can just make it in the laboratory. Okay. Now, if you look at these particles, this is how each and every particle looks like. This is how solid particles are present. These are how liquids arrange themselves. And these are how the molecules of gases are. So if you look at them, even if the solid particles are very close to each other, they have a slight movement in them. Similarly, liquids have a little more movement to them, and gases have maximum movement in the particles. What is this movement called? Can anyone tell me? What kind of energy do these molecules have? No, it is vibration. Of course, they are vibrating. But what kind of energy do they have? There's a particular name to this type of energy. Yes, good. This is kinetic energy. So each and every particle has kinetic energy to them, and as not potential, kinetic only. Potential is something when something is at rest. They are moving. Okay. So it's kinetic energy, and every substance has some or the other amount of kinetic energy. As in when we start changing the state, or as we start increasing the temperature, what will happen? Kinetic energy will also increase because the particles are moving much more quickly now. So in solids, kinetic energy will be the lowest. Then for liquids, it will be slightly higher. And then maximum kinetic energy will be in the gases because the particles are moving fastest in the gases, right? Any doubt, anyone? All right, great. Let's move forward. Okay, those of you who have switched off their video, I want you guys to switch on your video, please. In regular classes, I will simply throw you out of the class without even saying anything. Okay, I would like to see everyone on screen. Okay, great. All right. So changes that or changing state of matter, normally what happens is, now like I've already told you, that whenever the energy increases or whenever heat is being transferred to these particles, they will get more excited. The molecules will start getting more excited, and then they will start moving around. Now, first of all, there is a general rule that you have to know about energy. Any form of energy, there is a law of conservation of energy which states energy can neither be destroyed nor be created, or can neither be created nor destroyed. It can only be transformed from one form to another. So it only transforms from one form to another. That means all kinds of energy, whether it is sound energy, light energy, kinetic potential, heat, thermal, electric energy, mechanical energy, whatever kind of energy, they are not being created anywhere. They're just a different form of an energy molecule that already exists. So for example, the ultimate source of energy on planet Earth is the sunlight, the energy that is coming from the sun, right? Now, why is the sun has so much energy? Because it is made up of plasma or a group of gases, and these gases have a lot of energy which they're emitting out. Over a period of time, in a million of years, close to 50-60 million years, the sun will also run out of energy because it's not creating new energy. It is just transferring its energy to other parts or other planets. So now what is happening is when we provide heat to something, what is happening? Heat energy that is coming from a source, let's say you are heating up or boiling water. So that heat energy is coming from fire, right? Let's say boiling, let's say this diagram, if you see, a kettle is being boiled. So the heat energy is coming from fire. Heat energy is being transferred to kinetic energy inside the water molecules, right? And this kinetic energy is helping in change of state of matter. Okay. So what happens is each and every matter is made up of these tiny little particles, which we call atoms and molecules. What is the difference between atoms and molecules? Can someone tell me? Or are they the same? What are atoms? What are molecules? Atoms cannot live independently. Okay. Sure, that is the definition. Some atoms can live independently. Okay. And what about molecules then? What are molecules? Yes, what about others? Give it a try. It's okay if you're wrong. We're all here to learn. At least I will know what is everyone thinking. Just put whatever comes to your mind. Okay. Atoms are basically substances, or correct. So atoms are something, and if you have to technically define atoms, atoms is the smallest unit of matter. Okay, so the smallest unit of matter is known as atoms. And when atoms come together, we form a molecule, correct? So let's say in this case, H2O. H2O is one molecule of water. In this one molecule of water, we have two atoms of hydrogen and we have one atom of oxygen, which is combining together and giving you one molecule of water, right? So a matter can be made up of atoms also, they can be made up of molecules also, depending on what kind of matter we are talking about. All right, so they are made up of both. So what they're saying in this slide is that whenever there is transfer of heat, or whenever energy from the heat is coming to water or the liquid, it will create movement, and that movement is created because of increase in the kinetic energy, which will allow liquid to convert into gas or convert into steam. Okay. So this is how it happens. If you look at this, as in when the energy is added, that means as in when we are increasing the temperature or increasing the heat energy, adding up kinetic energy, there is change of state happening. So solids, you add energy, it becomes liquids. Liquids, you add energy, becomes gases. Gases, you add energy, becomes plasma. So as in when the temperature is increasing, we are getting solid, liquid, and gas. And as in when the temperature decreases, it cools down, it is going from gas to liquid to solid. The point at which the liquid converts to solid is known as the freezing point. All right, and the temperature at which liquid converts to solid, that is known as the freezing point. The temperature at which any liquid converts to gas is known as its boiling point. Okay, so basically you don't have to remember the boiling point and freezing point of all substances. You have to remember it for water. Freezing point of water is 0 degrees Celsius. So as in when the water will hit 0 degree, it will convert to ice. And boiling point of water is 100 degrees Celsius. For every molecule, for every type of matter, the boiling point and freezing point is different. Okay, it's not the same. For something, it can be 60 degree also, it can be 50 degree also, depending upon the nature of the substance. All right. So other than the temperature, even pressure can help in changing the phase or the matter. Can someone give me example of pressure being used to change the state of matter in your day-to-day lives? So if I apply pressure, correct, very good, Athar. Like LPG gas. LPG is liquefied petroleum gas. Okay, that comes to your houses either through pipelines or you have a cylinder at home. So LPG gas is liquefied petroleum gas. That means gas is pressurized for better storage and better transfer. And it is compressed, correct? It is pressurized, it is compressed. And when you compress it, what is happening? The molecules are moving here and there. You compress it. So the molecules come close to each other. When the molecules come close to each other, they will convert into a liquid. Okay. Now, when they're converting into a liquid, it is easier to store them. It is easy to transfer them, transport them, and it is easier to contain them also, because gases can't be controlled like that, right? And that is why when you switch on the burner, it is released in the form of gas because the pressure is released. Similar is the case with your CNG, compressed natural gas. So compressed natural gas is used in your most of the public transports nowadays. So there again, it is packed into a cylinder, pressurized into a cylinder. All right. So temperature can change the state and pressure can change the state. Any doubt, anyone till now? Yes, no, don't know. Okay, all right. Now there are certain terminologies that you have to know. Okay. So let me just, this is the chart that you have to remember. Very important. 100% questions come on this. Not one, more than one question can come on this. So this is an important chart where you see change in the form of state. So whenever solid is converting to liquid, we call it melting. When liquid is converting to solid, we call it freezing. When solid is converted to gas directly without the presence of liquid, we call it sublimation. And when gas converts to solid without forming a liquid, we call it deposition, direct conversion. Can someone give me an example of sublimation and deposition? Anyone? First, let's talk about sublimation. Any example of sublimation? Freezing and melting we see normally. Ice melts into water, water freezes into solid. Correct, Anayata. Dry ice. Very good. Dry ice is what? Sublimation. So in dry ice, we have solid ice or solid particle, and that converts to gas. Okay. Deposition, anyone? Gas being converted to solid. Gas is being converted to solids. Naphthalene balls is again sublimation. It's a solid being converted to gas. Deposition, anyone? No, evaporation is different. Evaporation is liquid to gas usually. We're talking gas to solid. Something is gas and we convert it to solid. Water vapor is also converts to liquid. No, it doesn't convert to solid directly. Okay, so sometimes what happens is certain gas molecules, for example, when we have salts with us, certain salts become vapors, and those vapors can be directly converted to crystals. That process is known as crystallization. We talk about that also. That crystallization leads to, so basically we try to boil the salt when we want to purify them, and they will directly convert to solid and not convert to liquid altogether. Camphor madura is again sublimation. Camphor converting to gas. So that's the other way around, solid to gas. I'm talking about gas to solid. Okay. Then let's come to gas and liquid. Gas to liquid is called condensation. That's what you see in the formation of clouds and all, right? And liquid to gas is known as vaporization. That means when, let's say, we boil water, it converts to gas or water vapor. Then we have gas being converted to plasma. We have ionization because the gas gets charged up. Okay. And plasma converting back to gas is recombination. These ions will come together and form normal gas again. That means, let's say this gas was hydrogen gas. Ionization, it became H plus ions, lots and lots of H ions. And then they recombine together. The H plus and H plus and H plus, they all recombine together and give you again hydrogen gas. So it's opposite. Okay. This is not that important. This part is not asked that much. You just need to know the terminologies. But this 3 change in state of matter is 100% asked. Okay. So here they have given just how temperature change occurs. So melting is increase in temperature, then vaporization, sublimation again are increase in temperature, whereas condensation and freezing and deposition are decrease in temperature. Okay, any doubt, anyone? If there is a doubt, you can ask. It's okay. I'll repeat myself. You can ask 10 times also. I don't have a problem. All right, great. Let's move forward then. Okay. Now, before we move on to the properties and how we separate these mixtures or separate the different types of matter, matter can be divided into different categories based on different properties. So first of all, matter is of two types. We have a mixture and we have a pure substance. Understand this carefully with examples I'll tell you. Okay. Then if you have a doubt, you can ask. So normally if you see, let's talk about pure substances first. Pure substances are substances that are usually combining together in a fixed ratio. Okay. And they cannot be separated by physical methods. All right. When I say fixed ratio, that means their combination is happening at a fixed quantity. You cannot change that quantity. Like in the case of water. Water is a pure substance. So in this case, there's a fixed ratio. That means two atoms of hydrogen and one atom of oxygen. Whether it is in the form of ice, whether it is in the form of liquid, or it is in the form of water vapor. Molecule of water will remain H2O only. Whether you have it here on earth or whether you take it in space, water remains water only. It doesn't become H2O2 or H2O3. Okay, so it's a fixed ratio. Fixed ratio of 2:1. Two molecules of hydrogen, one molecule of oxygen. Okay, so that's a pure substance. Now, pure substances are of two types further. One is a compound, another one is an element. Element is something that is made up of single type of atoms. That means, let's say we have hydrogen, oxygen gas, we have helium. These are only single elements or single atoms, or nitrogen. These cannot be separated at all. Okay, they will always remain like this only. There is no breaking them down. Okay, not H2O2. I'll not write H2O2. CO2 will be a compound, not an element. Okay, so elements are hydrogen, oxygen, helium, nitrogen, sodium, single element. You can't separate them at all. They will not exist otherwise. Yeah, boron, any elements like that. The elements that are given in your periodic table, they are all elements. Now, when two or more elements are coming together, two or more elements come together to give you a compound. Okay, so water is a compound. Two elements are coming together, hydrogen and oxygen. Carbon dioxide is a compound. Two elements are coming together, carbon and oxygen, right? Another example is, let's say, CFCs. No, CFCs are mixtures. They are not compounds. They are not pure substances, okay? Because they can be mixed in any ratio. They don't have a fixed ratio. Other than that, let's say sodium chloride, which is your table salt or common salt that you eat at home. So these are all fixed ratio, two elements coming together again, right? So two things you have to remember about a pure substance. Once they cannot be separated physically, and second, they are in a fixed ratio. And in a pure substance, the compound can be separated only chemically. If I want to separate out, I can separate out water through chemicals or chemical change. No, compounds are water, carbon dioxide, NaCl. Any two elements that are coming together are compounds, Ashish. Okay, I've written the examples here. Okay, now let's move to, electrolysis is used for water. Okay, now let's move to mixtures. Mixtures are substances that can be separated out physically. There are two types of mixtures. One is a heterogeneous mixture and the other one is a homogeneous mixture. Another thing about mixture is there is no fixed ratio. you want to mix it together in any ratio you can, it can still form a mixture. For example, let's say I want to make lemonade, right? I take lemon juice and then I add water to it. Now I can make lemonade in 1 glass also. I can make lemonade for 1 liter also. I can make lemonade in 5 liters also. It is up to me how much amount of lemon juice I want to add, if I want to add sugar or not, I want salt or not, I want to add some masala on it or not, that is up to me. So there is no fixed ratio that you have to only add 2 drops of lemon juice and 1 drop of water and 1 drop of salt and only then I'll get lemonade. No, right? So it's a random mixture or a random ratio. So that is a mixture. Now there are 2 types of mixtures, homo and hetero. Homo means, the term homo means same. And hetero means different. So a homogeneous mixture means any mixture that has the same kind of like visibility. That means you will not be able to see different parts in it. All right. So homo means same. All right. So homogeneous mixture is same visibility of all kinds of materials that are mixed together. Hetero is different. So normally if I mix, let's say I have salt and water, if I take a pinch of salt or I take a spoonful of salt and I mix it in water, it will completely dissolve in water, right? And I will not be able to make out which part was salt and which part is water, right? So it's a homogeneous mixture. Similarly, air around you. Air is a mixture which is made up of different types of elements, and you don't know that which part is nitrogen, which part is oxygen, which part is CO2, right? It's all the same. So it's a homogeneous mixture. Yeah. Water and juice also would be a homogeneous mixture. Lemonade also homogeneous mixture. Anything where you cannot see the different components together, there you will see that's known as a homogeneous mixture. Tea is also a homogeneous mixture after it is made, after it is ready, okay? Now, heterogeneous mixture, on the other hand, you can see different elements on it and they can be easily separated out. Okay. So for example, I want to make, if let's say you made bhel puri, right? Bhel puri has different elements. You have bhel also in it. You have tomatoes, you have onions, you have whatever. You have different types of chutneys and what all. And you can see each and every element in that mixture. So it's a heterogeneous mixture. Let's say I take sand and water. Sand doesn't dissolve in water. So that's a heterogeneous mixture. Okay. Other than that, another example of heterogeneous mixture could be anything. Let's say I mix pebbles and marbles. So again, you can see both the elements together. A pizza is a heterogeneous mixture. You can see the base of the pizza. You can see cheese on it. You can see different types of vegetables on it. That's also heterogeneous. Oil and water, correct. Paper and water, yes. Yeah, soil and stone. So any mixture where you can see all the type of all the types of elements on it. Yes, that is a heterogeneous mixture. Correct. Chalk powder and what, Siddharth? Chalk powder and something else has to be mixed. Chalk powder and water can be a heterogeneous mixture. Oil and water is heterogeneous. Rock and water is heterogeneous. Correct. All right. Any doubt in these? So now what we'll do is we learn how to separate these different types of substances, pure substances, elements, mixtures from each other, considering their properties. Okay. So first of all, yeah, so these are examples of certain pure substances or mixtures. Let's see, have you all understood? What is water? Pure substance or mixture? Water is what? Pure. All right. What about others? Yes. It's a pure substance, not a mixture. It is a pure substance. Water is a pure substance. What about sugar? Sugar is pure or mixture? Okay. Everyone quickly answer. It's a pure substance. Sugar usually has sucrose in it, which is a fixed ratio. Okay. Next, what about flour? Wheat flour or any kind of flour. Okay, it's a pure substance. All right. What about laundry detergent, which contains white and blue crystals? You know, there are different kinds of detergent powders that come. It's a mixture. Yes. What about Jello? Jello. Sure, is it a mixture or is it a pure substance? It's a mixture. It's a mixture. Jello is a mixture, not a pure substance. Okay, because you can mix the amount of water and then jelly and then make any quantity and any amount. It's not a fixed amount. Okay, what about cereal? Cereals are mixtures or pure substances? I'm getting different answers. Cereal, it's a mixture. Cereal is a mixture because again, there is no fixed method of making a cereal, right? You can have something where you can add a little more crunch. Some cereals are much more sweeter. Some have raisins in them. So what about honey? Okay, honey, everyone. Honey is a pure substance. Very good. Sand. Sand. Think about it. I'm getting mixed answers. Somebody saying mix, somebody saying pure. Sand is a mixture. It's not a pure substance. Again, there's no fixed ratio of sand. You can have some pebbles also. You can have some little bit of different types of sand can be there, right? It's not necessary that sand is made up of only one component or one compound or one element. It can be made up of different types of rocks. Pizza. Pizza is a mixture. Good. Okay. All right. Now, first of all, let's look at the different types or different ways in which we can separate out materials. First, separation can be done through physical methods. That means, let's say, if I have a mixture of pebbles and marbles, I can simply handpick them, right? Like if I want to separate out pebbles and marbles from each other, what I can do is I can simply handpick them. I don't have to do any chemical reaction on them or have to do any elaborate experiment on them. I can simply handpick. Next, we have different types of chemical properties. So the chemical properties of the mixtures, which are same as those of its components, that we will try to figure out. So let's say I have two mixtures. One of them is soluble in water. Another one is not soluble in water. So we will try to separate them out with the help of solubility as a property. Okay. So different properties will be used to different chemical and physical properties can be used to separate out the different components. Then energy. No energy change takes place when something is formed, that is no heat or light is taken in or given out. In that circumstance, we can change the energy. That means whenever a mixture is forming, if there is no change in energy taking place, that means it's not increasing in heat or not decreasing in heat, it remains the same. Okay. Then what we can do, we can use the property of energy change. Let's say I have two mixtures. I take pebbles and sand and I mix them together. And I take sand and water and I mix them together. So in that case, what is happening? Both are not showing any energy change, no? They are at the same energy. There's no evolution of heat. There's no absorption of heat. There is no change in pressure or anything. So I can change the heat and start separating them out. And then last is composition. The substance in the mixture can be mixed at any proportion. There is no fixed ratio for that. Okay. Any doubt, anyone? Yes, Athar. Energy, that means when you're mixing two mixture components in a mixture, there is no change in energy. Whether I mix sand and water, whether I mix pebbles and water, whether I mix, I mix water and let's say stones, there's no change in energy that is taking place. It remains at the same energy level which it was initially. Okay. Whereas in formation of compounds, we will have change. Okay. Now, whenever we have a solution, we have two components in it. One is a solute and the other one is a solvent. Okay. Solute is something that is present in lesser quantity. Solute is always present in the lesser quantity, whereas solvent is present in more quantity. When you mix them together, you get a solution. Okay. Now this solution again can be a homogeneous solution or a heterogeneous solution that we will discuss later. Okay. Now, let's say I have sugar and water. So in sugar and water, sugar will be the solute, solvent will be water, right? Because sugar will be added 1 spoonful of sugar and in 1 glass of water, if I'm adding it, that will be. So now solute can be a liquid also, it can be a gas also, it can be a solid also. Similarly, a solvent can be liquid also, gas also, solid also. Okay, but mostly whenever we're making solutions or whenever we are making aqueous solutions, because mostly when we do chemical reactions, we make aqueous solution. Okay, aqueous means we are mixing it in water. So mostly the solvent is water. In 90% of the solutions, solvent is water. And since water is used as a solvent in most of the chemical reactions, water is known as a universal solvent. Okay, because most of the solutions that we make it in the presence of water only. Dirty water is a mixture. Yes, Rehas. Okay, so there are certain examples given here in this table, if you can see. So solvent, they've written the liquid in which a solute is dissolved to form a solution. It doesn't have to be liquid. It can, like I said, it can be a solid also. It can be a gas also. It can be liquid also. All three are possible. And the smaller quantity of component that changes the state in the form of solute, in forming the solution, that is the solute, and both of them will mix together and form the solution. Example, water and lemonade. A lemonade mix will give you lemonade. Iced tea and sugar is giving you sweet tea. Milk and chocolate sauce is giving you chocolate milk. And boiling water and jello powder is giving you jello. Any doubt, anyone here? Yes, no, don't know. All right. Let's move forward then. Okay. Now, soluble versus insoluble. This is one of the major physical properties that we use to separate out materials, or we try to define solutions or on the basis of their solubility. So whenever when we call something soluble, it means that it completely dissolves in the solvent. Now the solvent can be anything. Mostly the solvent is water only. So we are talking about solubility in water, but it can be anything else also. So when the solute completely disappears or evenly mixed inside the solvent, then we call it a soluble substance. And whenever the solute doesn't mix in the solvent, then we call it insoluble. Example, salt and water are soluble. Salt is soluble in water and oil is not soluble in. Okay. This is one of the major reasons of, or major examples also when we come to aquatic organisms. So aquatic organisms can breathe in oxygen or breathe in CO2 for in the case of plants, with the help of this ability of water to dissolve all the gases. So CO2 and oxygen both are soluble in water. Okay. So what happens is, if you've seen a fish, if you've been to an aquarium or an aquatic world or something, you see the fish keeps on opening and closing its mouth. They continuously keep on drinking water. So what they're doing is they are breathing actually. They take in all the water, and water has dissolved oxygen in it. That oxygen will be utilized by the body of the fish, and the remaining water will be let out. It will go out through the gill slits at the back of their ear. Okay, oxygen will be dissolved. Similarly, plants also diffuse or absorb all the water inside themselves. Along with the water, they will take in oxygen also, they will take in CO2 also, and they can conduct photosynthesis and respiration both. Okay, so aquatic animals are completely dependent upon the ability of oxygen and CO2 that they can dissolve in water easily. Any doubt, anyone? Okay. All right. Next property is miscibility and immiscibility. This is usually for, they don't convert anything. They are taking in the water. Water is, let's say oxygen is dissolved in water. So oxygen is absorbed by the body and water is thrown out of the body. Okay, that is done by the gills. So when they take in water, all the water is diffused. So all the oxygen diffuses into the gills and then it goes into the bloodstream and water is thrown out. If you've seen whales and dolphins also, they have a blowhole on the top. So they blow out water, whatever is not required. Rest they will take in. Now next is miscibility and immiscibility. Miscibility and immiscibility is mainly for liquids in liquids. Okay, so liquids that are soluble in each other are known as miscible liquids, and liquids that are insoluble in each other are known as immiscible liquids. So miscible liquids, for example, alcohol and water, and immiscible liquids, oil and water. So in the case of miscible liquids, you will not be able to make out which one's what. You will not be able to make out where is alcohol, where is water. Whereas in the case of oil and water, you can actually see a line here which separates out the two liquids completely. So liquids which mix together in all proportions and form a single layer. That means you can't distinguish between the two, is called miscible liquids. They are used or they are separated through fractional distillation. This we'll study later when we come to regular classes in detail, what is a fractional distillation. And immiscible liquids are liquids which will form two separate layers. They can simply be seen with your naked eye and they can be separated using a separating funnel. This also I'll discuss in the regular class. Any doubt in the terminologies? Right now we're just talking about the terminologies. We're not going to details as of now. Okay. This I've already told you: transparent, translucent, and opaque objects. Transparent, substances which all light passes through it, so you can see clearly through it. Translucent, where you can see hazy or not a very clear picture, but still you'll be able to see some of it. And opaque, you cannot see anything. Now these terminologies are important for you to understand. It will not come as a direct question. Okay, the questions will come in example form. So for example, let's say a question that came last year was that this is person one standing. So just understand the question, then you can answer it. This is person two. So this is B. Okay. Then we have here C standing, and then we have D. Okay, these are four people standing. And in between we have certain materials. So we have few of the materials here. Materials I'm going to name as 1, 2, 3, 4, and 5. Okay, understood the setup? All right. So first scenario is if I remove 5. If 5 is removed, then C can see D clearly. If 5 is removed, C can see D clearly. Okay. If 4 is removed, C cannot see D clearly. All right. Next is if 3 is removed, B cannot see C clearly. All right. If third is removed, B cannot see C clearly. And if 1 is removed, then A can see B clearly. Completely. Okay. And last is if 2 is removed, then B can see C clearly. Now tell me which is an opaque object or the opaque screen between all of them. Which all are opaque? 1, 2, 3, 4, and 5. Which all are opaque? Just 4 and 1. What about 5? There are 4 people standing, A, B, C, D. If 5 is removed, then C can see D clearly. If 4 is removed, C cannot see D clearly. Okay, if 5 is removed, C can see D clearly. But if 4th is removed, D cannot see. Okay, 5 removed. 5 is removed. C can see D. Okay. Right? If 4th is removed, C cannot see D clearly. There is no translucent, there's only transparent and opaque in this. Now, if 3 is removed, B cannot see C. But if 2nd is removed, then B can see C. Okay. Then when A is removed, A can see B clearly. Now tell me which is an opaque object. What is opaque in all of them? From 1, 2, 3, 4, and 5, what is opaque? Okay. Nirupama, we are just going through a demo for sorting and separation. Just go through the recordings if you haven't, you could join earlier or you could see it on the Facebook page also. Okay, Siddharth is saying 4, 2, and 1. What about others? Which one of them is opaque? It's an easy question. Yes, I'm still waiting for others to answer. I'll repeat myself. These are different screens that are present between A, B, C, D. Okay. There are 2 screens between B and C and 2 screens between C and D. 1 screen between A and B. Now, if I remove the first screen, A can see B clearly. As of now, nobody is able to see anyone. All are in their own spaces. Nobody is seeing everyone initially. But when I remove A and B, from A and B, I remove 1, I can see A and can see B very clearly. From B and C, first if I remove second one, then B can see C. But if I remove third, then B cannot see C. Okay. Then coming between C and D, if I remove fourth one, then C cannot see D. But if I remove the fifth one, only then C can see D. Yes, it is fifth, second, and first. 5, 2, and 1. I've already written the question here. Perhaps I've already written the question on screen. So 5, 2, and 1 are opaque because when I remove 1, only then A and B can see themselves. That means there was a blocking in between. Then when I removed 2, B could see C. That means 3 is transparent, right? But when I was removing 3, then B could not see C. That means second was opaque. Then similar thing is happening between C and D also. When I remove the fifth one, only then C can see D. And if I remove fourth, C cannot see D. So it's 5, 2, and 1. Understood? This is an easy one. They'll ask you translucent also, transparent also, opaque also, all. Okay. So this is for all the types of questions. Okay. Now these are the properties of different materials in terms of their physical nature. Okay. Either they can be hard or soft. They can be smooth or rough. They can be bendy or very rigid. They can be shiny or dull, or they can be waterproof and leak. All right. This will help you to determine the different types of matter and then use these properties to differentiate between them and other types of materials. So let's say if I take the example of wood and stone, between wood and stone, wood is slightly smoother, stone is rough. Metal and brick, metal is shiny, brick is dull. Wool and cotton, what can be the difference between wool and cotton? How will you differentiate between wool and cotton? Wool is soft and rigid. Sure. Wool is rigid. No. Then correct. Wool is warm, cotton is cool. That is correct. Okay, then plastic and diamond. Plastic is softer, right? Diamond is hard. Bendy means something that can be twisted around very easily, and rigid that cannot be. Okay, and leather and glass, a leather belt and glass. So leather belt and glass can be your rigid and bendy. So a leather belt, of course, you can twist it around, move it around. A glass you can't. Ceramic and ice. Yeah, plastic. Cheap and expensive you can't. I'm talking about physical difference. Okay. Ice, correct. Ice can be converted to liquid and ceramic can't. And then different types of fabrics can be from the touch. You can obviously make out what is cotton, what is polyester and all that. Ceramic will be waterproof, correct. Ice will be very good. All right, so I'm going to stop here. We will continue obviously with this chapter when we come to the regular classes, right? So I hope you all like the demo, and I hope I'll be seeing all of you in the regular classes, right? So that's it from my side, and I'll meet you all when we start with the regular classes, okay? Thank you for joining, everyone. Bye-bye. Good night.